Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is Walking Robot Simulation. So the problem statement goes like this: a robot on a infinite XY plane starts at a point 0, 0 facing north, and the robot can receive a sequence of three possible types of commands. The first command is -2, that indicates that you have to turn left 90 degrees. Okay, basically you will be changing your direction. Okay, because you know, if we talk about the directions, the four directions that will be there. So this is north, east, south and west. Okay, so initially you are here 0 colon 0 or 0 comma 0, sorry, and you are facing in north. So if you want to have a turn of 90-degree towards left, then you will going towards west, and if you want to have a turn of 90-degree towards right, then you will be going towards east. Okay, so then the third type of command is the second type of command is -1. Okay, which will also be turning 90 degrees but in right direction. The third type of command is that you will be having a number between 1 to 9, indicating the number of units you have to move in the given direction you are facing. Okay, and some of the grid squares are obstacles. Okay, so you are moving in a xy plane and there are some obstacles also along the way. The ith obstacle is at a particular grid point which is given by obstacles array, and each entry in this array is a coordinate having x and y. Okay, if the robot runs into an obstacle, then instead of moving ahead, it will stay in its current location. Okay, so for example, if let's say the robot was moving in this direction, and after that there is an obstacle. Okay, so the robot will be staying here only at this particular point. It will not do anything, stopping just before the obstacle. Okay, so this is what the problem statement is saying here. Okay, now moving further, it will stay in its current location and move on the next command, and it will wait for the next command that you will give or it will be given. Okay, and then only it will move. Then what you have to do is you have to follow all these rules or run a simulation in a way, and then you have to return is maximum Euclidean distance that the robot gets from the origin squared. Okay, so if the distance is 5, then you see you will be returning 25. Okay, so this is what you have to do. Let's take this particular example and try to understand it even further. Okay, so let's remove this particular diagram and let's paste the. Okay, I think we should be copying only this much. It should be fine, or you can copy the input only. Okay, and let's again try to paste. So this is the input, and for the sake of simplicity, let's copy this explanation also. Firstly, let's reduce the size a little bit so that it will be adjusted. Yeah, now we can copy this much separately. So this is the example, the first example. So let's say this is the input given to you and there are no obstacles. Okay, so you will be anyways following this all these all directions. So starting from the origin as mentioned in the problem statement, and you are facing north. Okay, so you will be moving 4 units towards north. Okay, and it is mentioned in the problem statement that there is a note which I forgot to discuss with you, that north means positive y direction. So the coordinate system is like this. Okay, so this is positive y direction and this one is negative y direction. This is positive x, this is negative x. Okay, so south is minus y and west is minus x and east is plus x. Okay, so and let's mark the directions also. So this is north, so this is east. Okay, and this is south and this is west. Okay, so initially you moved 4 units towards north. So since it was a positive y direction, so that's why 4 units will be covered in positive y direction. Okay, then you turned right because uh, you know see a minus 1. So minus 2 means left 90 degree and minus 1 means right 90 degree. Okay, so if you turn right 90 degree facing north, then the right thing is this east direction. Okay, so now your current direction becomes east. So you already covered 4 units here. Okay, and then you moved 3 units here. Okay, because the next value that you saw was 3, which was a positive value. So your current coordinates are 3 and 4. Okay, so 3 here, 3 comma 4. So this is your current location. Okay, the farthest point that from origin you are at. Okay, and if you square the coordinates, 3 square plus 4 square, it comes out to be 25. Okay, so this is what you have to return. Okay, and you have to basically do this every time you execute one instruction. Okay, because you were asked to return the maximum Euclidean distance. There might be a situation that since we are considering the distance from origin. Okay, so this was your origin 0 comma 0. So there might be a situation that you went here first of all and then you came back to this point, but and this was your ending point, but at some point of obeying the instructions, the robot came to a point which was more further than the ending it will be at. Okay, so in that case you should be checking this squared distance every time you follow one instruction. Okay, so and return the maximum out of all the possible uh, coordinates that the robot will be at. Okay, so let's see how we will be solving this particular problem. So in order to solve this particular one, the only thing that you know we can just run a simulation of it. A straightforward approach will be just to run a simulation of the instructions that we are provided. Okay, but we cannot do so because there is a little constraint, or we need to think about how to solve that constraint. The constraint is that there is a 2D grid system. Okay, and there are some obstacles also. So how would you be knowing while moving the robot that you have to stop before that particular obstacle? Okay, and if you are uh, trying to think of a naive way, and before thinking of an approach first, it would be advisable to have a look at the constraints. Okay, so according to the constraints, the length of the commands that will be given to you will be of order 10 raised to power 4. Okay, and the commands will be either -2, -1, or a positive integer ranging between 1 to 9, both inclusive. Okay, it's already mentioned in the problem statement also. And the obstacles length, the number of obstacle points will be of order 10 raised to power 4. Okay, and the ranges in which your coordinates will be lying will be from minus 3 into 10 raised to power 4 to 3 into 10 raised to power 4. Okay, and there is further mention that the answer is guaranteed to be less than 2 raised to power 31. So it means that it will be able to be fitted into a integer data type. Okay, so if you are thinking of a naive approach of running the simulation, you will be saying that, okay, what we will be doing is we will be moving robot step by step. Okay, the first thing that you will be doing is moving robot step by step. By step, I mean that if you are to take k steps, then you will take first step, then you will and at each step you will be doing a check whether there is a coordinate that is a obstacle or not. Okay, okay, for each coordinate, for each current coordinate, you can say, you will check for obstacle. Okay, so this is a naive approach of doing it. Why I am saying it? Because it can be optimized further. See, this particular thing will be resulting into a quadratic time complexity. Okay, quadratic means that if the number of, see, the number of coordinates is the number of commands is of order 10 raised to power 4. So in a way you can be moving the robot order of 10 raised to power 4. Okay, and for each coordinate you are saying that each of these k steps you are saying that you will be checking the obstacles array. Okay, and for doing the check on the obstacles array also, see, and the coordinates are also in this range. Okay, and for obstacles array, the obstacles array can be as large as 10 raised to power 4 order. So it will be, you know, this much. So that's why quadratic time complexity will be there. So in order to avoid getting time limit exceeded, because what happens is if the number of operations that your program will be requiring exceeds or become equal to a limit of 10 raised to power 8 operations. Okay, so this is kind of a ops limit, you can say. Then your solution might not be getting accepted and you will be getting a TLE. Okay, so that's why in order to avoid that, you have to somehow optimize this lookup of coordinates. Okay, lookup for obstacles you have to optimize, because see, you cannot optimize uh, or I was, at least I was not able to think of a way to optimize the first step of moving robot step by step, and it was mentioned in the problem statement also. The mention was that the robot will be moved k units, 1 unit at a time. Okay, so you have to do this, and the only option with you is that you have to optimize the second step, the lookup for obstacles. Okay, obstacle lookup, or you can say you have to optimize. So how we can optimize this? Instead of doing a linear traversal over the obstacles array, we should be thinking of something that should be giving us this lookup almost instantaneously. So what we can do here is we can have make the use of hashing. Okay, so hashing is nothing. Uh, I will be providing a link of an article describing what hashing is and how and when to use it. Okay, so please head over to that link if you are new to hashing. What I will tell you is a very naive way of explaining it would be that if there are two coordinates for this particular problem we are talking about, x and y, we want to convert this 2D coordinates into somehow a 1D coordinate, okay, or a number, just you can say 1D coordinate, okay. So how we will be doing so is, see, firstly we need to check what are the ranges of these x and y, okay. So it is ranging from minus 3 into 10 raised to power 4 to 3 into 10 raised to power 4, okay. So this is the range. So since this was the range, uh, this is the entire range is about, you can say, 6 into 10 raised to power 4, okay, units, okay. So what we can do here is we will keep x as it is, and then we will multiply this 6000, 6 into 10 raised to power 4, okay. And we will take not this particular number, we will be taking a prime number, okay. So why we are taking the nearest prime number is, or any prime number, so that uh, this particular value that you will be generating, basically you will be generating this value, okay. You will be using this formula to find a 1D coordinate, okay. So we are using a prime number because, see, it have one or itself as its divisor. So when you will be getting this value, there are very few chances that different coordinates will be having the same hash value or same 1D coordinate, okay. So it reduces the chances of two different coordinates having same hash, or this 1D coordinate, in a way I am saying it hash, okay. So this two different entities having same hash value is called collision in terms of hashing. So this kind of situation will not be arising. So in a way you are forming one to one mapping, okay. One this side is the coordinates and the other side is the hash value, okay. Or you can say the 1D coordinate, okay. So once you are having this hash value or 1D coordinate, which will be just an integer value, so you can use a hash map now, okay, for fast lookups, okay. Now you would be able to use a hash map, not hash map, sorry, hash set, okay. So hash set can be used. Hash set will be able to tell you in order of one time complexity whether it contains some element or not, okay. So for the obstacle lookup, it will just take you order of one time complexity, okay. So the very major problem or the main thing that we have to think of in this particular problem was to do a fast obstacle lookup, and this is solved, okay. The solution was that you converted the 2D coordinate into somehow a 1D value or a single integer and stored it into a hash set, and hash set will be able to tell you that a particular hash value is there in the hash set or not, okay. So this hash set will be storing the obstacles, so the obstacles will be going inside this hash set, obstacles hashes, you can say, okay. And since you will be moving step by step, so at each step you must be having some coordinate, let's say x dash y dash. So it, you will generate a hash value, let's say h dash. So you will see whether this h dash value is already there in the hash set or not. If it is there, then it means that the following coordinate will be the obstacle, and you will stop your robot then and there only and wait for the next instruction. Okay, so this is how it will be working out, and we will be seeing it in the implementation part. So let's see the implementation part, how we have used this hashing approach for fast obstacle lookup and implemented the rest of the simulation. Okay, because if we go on discussing without code any further, then I think it may confuse you. So in order to avoid that and also make this solution video a little concise, so it would be better for me to take the code to the next slide. Okay, so let's take the code here. So I think this should be visible enough for you, and let me adjust it a little bit. Okay, now the code is adjusted, and let's remove this toolbar also, and let's discuss what we are doing here. Okay, so as we already discussed, to cover the entire range and to avoid collisions, we will be needing a prime number that covers this range. Okay, so prime number, because prime numbers ensures that the hash function is less likely to produce patterns. By patterns, I mean that collisions, you can say. Patterns is like some value of hash being repeated. So in a way, pattern is there. Okay, which lead to collisions. Because prime numbers will be reducing the likelihood, because the it will be having only two divisors, which is the number and the other one is 1. Okay, so this is why we have used this particular value, and then it comes to doing the hash and storing it in this particular set, hash set. Okay, which will be doing the lookups in order of 1. So we will be traversing the given obstacles array and storing the obstacles, and firstly we will be generating the hashes. Okay, and now let's have a look how we have implemented that hash function. So as we already talked about, for x and y coordinates, you will be doing x plus 6, uh okay, this particular number into 60,001 basically. Okay, into y, and you will be using this as your hash value. Okay, or you can say 1D coordinate. Okay, so okay, I think till now you are clear. And then once you are having that hash value, you will just be storing it inside the hash set. Okay, for fast lookups of obstacles. Okay, so once you covered this particular part, then you will be moving to the simulation. Okay, so this entire thing going forward will be your simulation. Okay, so this is your simulation part. So first of all, the thing that you have to return is the maximum distance square. Okay, so initially I have set it to 0. Okay, and see what we are doing here is we are giving values to the directions. So if we talk about the directions, north, east, south, west. Okay, and we will be moving in a way in this clockwise direction. Okay, so in this direction we will be moving, and so north is assigned a value of 0. Okay, I will tell you in a bit what these values are. East will be 1, and then so on, 2, and west will be 3. Okay, so you see, these values are nothing but the indices of this particular array. Okay, directions array. Okay, and as mentioned in the problem statement, north was plus y, south was minus y, east was plus x, and west was minus x. Okay, so this is what it represents. So initially you were starting at the origin 0 comma 0. Then if you have to go in the north direction, then you will be going in positive y direction. Okay, which is this 1. And if you want to go in east direction, then you will be going in positive x direction. Okay, which is this 1 on the x side. Okay, similarly there are the entries for the other directions. So that's why we are assigning them indices in this particular array. So it will help you to determine the current direction and the current coordinate. And initially, as mentioned in the problem statement, you will be starting at the origin. Okay, so then you will just follow the commands that will be given to you. Let me change the color. So then you will be following the commands one by one. Okay, if the command is a a number which is greater than 0, it means that it is the number of steps that you have to take in the direction that you are currently facing. Okay, for that you should be knowing which particular coordinate you will be adding the values. Okay, so you should be getting one of the entries in this particular directions array. Okay, and it will be nothing but current direction index or the value that we have assigned in the directions array. Okay, and it will give you the coordinates that you will be adding at each step. Okay, so the new coordinate will be generated by this. Okay, so it is the row, in a way you can say, or x coordinate you are generating, and this is the y coordinate. Okay, and these entries are also representing x and y in a way. Okay, so x and y, so you can say increments in x or y to be more specific. Okay, and then once you have the new coordinates, you should be checking that are we going into an obstacle or not. Okay, so firstly you should be getting the hash of the current coordinate, and you will be looking that hash in the obstacles hashes. Okay, and if it is a non-obstacle hash, then you will break, saying that we cannot proceed further, and the robot will wait for the next instruction to be given. Okay, otherwise if that's not the case, then you will be moving further. So in that case your new coordinates will be updated in this particular coordinates array. Okay, and then once you have completed all the steps, okay, you will be updating your max distance square. So you will be seeing your distance after you just moved k steps, or the number of steps that you were told to move. Okay, every time you will be doing so, you will be updating this maximum distance square. Okay, so it will be the distance of sum of x square plus y square. Okay, so you will be updating this, and if the current command is not a positive number, then it means that these are the direction commands. Okay, so see, if the current command is -2, then it means that you have to turn left. Okay, and since you are going in this direction, clockwise direction, in a way you are always going towards right. So if you are facing this direction, then going right will be south. Okay, and if you are facing south, then going right will be this. So it's easy to go into right direction. You will be just if your current direction is represented by an integer, if you want to go to right of north, you will just say okay, do this, and you will be pretty much done with it. And this modulo is just for the sake of keeping it between 0 to 3. Okay, modulo with respect to 4. So then you will be getting the new direction, which is 1, by the way, is east. Okay, but what if you want to go in the left direction? Okay, so if you are currently facing north, let's say you are in this direction, and you want to go towards left, then you should be going towards west. Okay, but uh, since you are moving in one right direction only, so you should be able to skip these two. Okay, and somehow land on west. Okay, so see, if you add 3 to the current direction, which was being represented by 0, and add 3 and take a modulus with respect to 4. As I already told you, this modulus with respect to 4 is just for the sake of keeping the direction values in this range. Okay, then you will be able to move in a way to the left direction. Okay, so that is why down there, if you want to move in -2, then you have to go 3 places in one go. Okay, so that's why this +3. Okay, and modulo 4 is already discussed. And if you want to go to rights, then just go one place uh, clockwise. Okay, and take modulo with respect to 4. So this is how you will update your current direction if the command is a direction command. Okay, and then simply you will be returning your max distance square. Okay, so this is the whole logic and how you will be solving the problem. Okay, and if you want to have a discussion on the complexities, the time complexity wise, if let's say the obstacles array, okay, was of size, let's say uh, what should we take, a, and the particular commands array was of size b, then see, you were just doing couple of linear traversals of these arrays. Okay, for the first part you were covering this obstacles array, which was a linear traversal, and then you were again doing this linear traversal of the commands array. Okay, and you can ignore this part because you know in the constraints it's mentioned that the number of steps will be ranging from 1 to 9. Okay, that you have to take. So 9 into the size of the commands array will be we will be able to ignore. It will be order of b only. Okay, so the overall time complexity in this case will be order of a plus b. Okay, and if we want to see what will be the space complexity wise, since you are only storing the obstacles, number of obstacles, so it will be order of a. Okay, so these will be the complexities, the numbers of obstacles you are storing in this hash set. Okay, that you were using, so only this much extra space was used by you. So I hope you are able to understand, and if you are still having any doubts or any queries in general, then please feel free to ask them in the comment section. And I really hope this solution video added some value to your journey of honing your DSA skills, and keep solving more and more problems, and I will be seeing you in the next video. Thank you for watching.